Day 2 of standard number 4, which has to do with angles and lines crossing each other, forming angles. Yesterday I jumped right into the fire and gave you 3 lines. I gave you 2 lines and then a third line that crossed both of them, and it created 8 angles. So I'm going to back it up a little bit today. Perhaps in the future I'll do this lesson first and that one second. But regardless, here you go. Backing it up. I've got a line there from A to B, and I've got the words linear pair and vertical angle, because what I'm going to do eventually here is cross AB with another line, and it's going to create 1, 2, 3, 4 angles that are either going to be linear pairs or vertical angles. Before I do that, I'm going to explain how to build up to that by explaining the linear pair first. So let's just start with a straight line from A to B. This straight line from A to B, if I put a protractor on there, which I just did, there's my protractor, people. That protractor tells me that there's 180 degrees in this straight line. From that point A all the way over to point B is 180 degrees. You've all seen a protractor. You probably all know that there's 180 degrees on a protractor. So that's our baseline here, 180 degrees in a straight line. Let's review, most of you knew that. Let's say we cross this line now with another line, like I said I was going to do. Okay, there's another line. I just crossed AB with another line. Now let's put the protractor back on there. There's still 180 degrees from A to B. A to B is still a straight line. There's still 180 degrees now, but we just split that 180 degrees into 2 parts. We have this part over here, which is from 0 all the way to about, let's say, 120 degrees. So this angle right there would be about 120 degrees, and the rest of it here from 120 to 180 is 60 degrees. Those add up to 180. It doesn't matter where I drew this line. Okay, let me erase this line and draw another one. Let's say I draw the line like this. I still split my original AB line into 2 parts that are going to add up to 180. All right, I still split it. Right now, instead of 120 and 60, now this first angle goes to about 35, so this angle looks like it's about 35 degrees, and this one over here is 145 degrees. Those 2 numbers still add up to 180. Doesn't really matter what the degree measures are. I'm just trying to make the point here that no matter where you cross AB with another line at, you're going to split AB. You're going to create 2 angles that still add up to 180. Because that's not going away. It's still 180 degrees from A to B. If you split it into 2 angles, those angles are going to add up to 180 to 180 degrees. You can put those 2 angles together to make a line, basically. 180 degrees is a straight line. This angle and that angle form this straight line right here. They add up to 180 degrees. That's called a linear pair. When you have a pair, pair means 2. When you have 2 angles right next to each other that add up to 180 degrees, they're called a linear pair. So, hopefully you understand that. A linear pair, let me put numbers in here. 1, 2, 3, and 4. So I've got 4 angles I just made by crossing AB with another line. Call them angles 1, 2, 3, and 4. Angle 1 and angle 2 go in the linear pair column. They make that straight line, the 180 degrees from on a straight line. That was like 35, and that was 145. It could have been 60 and 120. Could have been 80 and 100. It doesn't matter. They're going to add up to 180 degrees because they're part of a straight line. They're a linear pair. There's more than just one answer for a linear pair column here. There's actually 4 answers because we have 4 lines, essentially. We really have 2 lines, but you have the bottom and the top, or the left and the right of each line. So what do I mean? When I drew that line right here, not only was there 180 degrees in AB on top of it, there was 180 degrees from A to B on the bottom of A to B. So when I drew that line, now 3 and 4 also add up to 180 degrees. That's like 40, and the rest of it's 140. So angle 3 would be like 40, and that'd be 140 or whatever. Okay, so those add up to 180 degrees as well. So angle 3 and 4 is also a linear pair. Now, the line I drew to cross AB is being split by AB, meaning this line that I drew also has 180 degrees in it, and AB split it on the left-hand side into 1 and 4, so 1 and 4 make a straight line. The line I drew also got split by AB on the right-hand side of that line, so 2 and 3 make 180 degrees or a linear pair as well. So we've got angles 1 and 4, and we also have angle 2 and angle 3. So we've got 4 sets of linear pairs when two lines cross each other. They're just the ones that are right next to each other. 3 and 4, 4 and 1, 1 and 2, 2 and 3, 4 sets. Okay, vertical angles are the ones that are across from each other, and they're going to be equal to each other. So let's go back to the protractor. All right, angle 1 is going to be 30 degrees, and angle 2 is going to be 150, it looks like. So 30 and 150. Well, we already have right here angle 2 and angle 3 are linear pairs. So if angle 2 is 150, angle 3 must be 30 because they have to add up to 180. If I put the protractor on there, yeah, that looks about right, 150 and 30. So this angle is also going to be 30 degrees because 2 is a linear pair with 1 and 3. It makes up a straight line here with 2, and then 2 also makes a straight line over here with 1. So if 2 is 150 and it's making a straight line with another angle, that other angle must be 30 degrees because 150 plus 30 is 180. If we're making a straight line, you got to have 180. So 3's got to be 180. 1 also has to be 180. I'm sorry, 30. They add up to 180. So 3 has to be 30 and 1 has to be 30. Now, what about 4? Well, 4 is a linear pair with 1, 4 and 1. 4 is also a linear pair with 3. Where's that at? Right here, 4 and 3, right above it. So if this is a 180 degrees from here to here, that's a straight line, and that much of it's 30, the rest of it must be 150. Same with 3 and 4. If from here to here is a straight line, from A to B is a straight line, that's 180 degrees. If the right-hand part of it on the bottom is 30, the left-hand part over here must be 150. So look at what we did there. We filled in all of our angle measures, and the ones across from each other are equal to each other. That's vertical angles. The ones that are across from each other are equal to each other. So there's only 2 correct answers for vertical angles here, and that's angle 2 is equal to angle 4, but we don't use the symbol equal. We put a little squiggle above it, and that's called congruent, and it basically means the same thing as equal, just fancy because we're fancy now. So 2 is congruent to 4, and 1 is congruent to 3. So every time 2 lines cross, you have 2 sets of vertical angles that are equal, and you have 4 sets of linear pairs that add up to 180, and there's a special name for angles that add up to 180, and that special name is called supplementary. That's a U's. S-U-P-P-L-E-M-E-N-T-A-R-Y. Supplementary. That really looks like an O. That's going to bother me. It should be a U. There we go. That's a beautiful U. All right, supplementary means that they add up to 180. So linear pairs add up to 180. They make a straight line. Vertical angles are equal to each other. They're diagonal from each other. All right, there's your lesson on linear pairs and vertical angles. Now, we're going to use the knowledge that you just filled your brains with to solve some algebra problems. So for example, here's my two lines that cross. I'm going to say this one is 120 degrees and this one is 2x plus 20. And I want you to figure out what is x. We need to solve for x here. Whenever you have an algebraic expression to solve for the variable, you got to set this whole thing equal to something, or you're never going to be able to solve it. I could put a 10 in there and say 2 times 10 is 20, 20 plus 20 is 40. There you go. X is 10 if you want this to equal 40. Well, I don't want it to equal 40. I want it to equal what it's supposed to equal. And what it's supposed to equal is 120, because these are vertical angles. This angle right here is equal to that angle because they're vertical angles. So we can set these two things equal to each other because those two angles are equal to each other. So that's what I'm going to do. I'm going to say 2x plus 20 is equal to 120 because they're vertical angles. This angle, whatever it is equal to this angle, whatever that is. And in this case, they're 120 and 2x plus 20. So those two things are equal to each other. Now you can solve for x, a simple two-step algebraic equation. You subtract 20 to the other side to get 100, and then you divide by 2, and you get 50. So x is equal to 50, and that's right. If we plug a 50 in for there, 2 times 50 is 100, 100 plus 20 is 120, and that's what we wanted. We wanted this angle to equal 120. And to make that happen, x has to be 50. So that's the answer to that one. X is 50. Now this works for the pictures that I were drawing you yesterday with one stipulation. Yesterday, these two lines that I drew were not parallel. Today they are, and that's what those arrows mean. Arrows mean that lines are parallel. So those two lines are parallel, and if I cross them with a transversal, a third line, now my alternate interior angles are equal, my alternate exterior angles are equal, my corresponding angles are equal, vertical angles are still equal. We've got all these equal angles now. All those different vocabulary words I showed you yesterday, alternate interior, alternate exterior, corresponding, those are all equal to each other. So you could have this angle right here be 3x minus 10, and you could have this angle right here be 110 degrees, and I could say solve for x. And you would hopefully say, okay, these are both in the upper right-hand corner of their set of four angles. Therefore, since they're in the same corner, they're corresponding. And since the lines are parallel, then corresponding angles are equal to each other. So you would set those two things equal to each other just like we did with the vertical angles, and you'd have 3x minus 10 equals 110. Add 10 to the other side to get 120. Divide by 3 to get 40. So x is 40 in this problem. And that's right. 3 times 40 is 120. 120 minus 10 is 110. So it works. They're equal to each other. Corresponding angles. So it works for vertical angles. You can set them equal to each other. It works for corresponding. You can set them equal to each other if your lines are parallel. It works for alternate interior and it works for alternate exterior, assuming that for these three, these two lines are parallel. As long as those lines are parallel, this is going to work. Now, it can get a little bit trickier than this as far as a little bit more than just a simple two-step equation. Instead of giving you the degrees there, they could give you another algebraic expression. I probably gave you a bad example. Some of you are probably saying, Mr. Vanderweis, that's an acute angle. There's no way that's 110 degrees, and you are absolutely correct. So sorry about that. I should have made up another number that was less than 90 here. But regardless, let's say instead of a degree measure, I give you another algebraic expression. 2x plus 40. All right. Now it's like, whoa, slow down. What do I set this equal to? What number am I going to use here? Well, you're not going to use a number. You're going to set this angle equal to that angle, and whatever is inside those angles, that's what you're going to use. So you have to do 3x minus 10 is equal to 2x plus 40. And now you have to solve the algebraic expression by getting your x's together. So I would subtract the 2x over to the 3x because you got to get those x's together. You got to move one of them. You're either moving the 3x over here or the 2x over to there. And it's better to move the smaller one because then your x's stay positive. So I'll subtract the 2x over here to make it a single x. 3 minus 2 is 1. So I have x minus 10 equals 40. Then I'll add my 10 to the other side to get x by itself, and x is equal 50. Does that work? 3 times 50 is 150 minus 10, that's 140. How about up here? 2 times 50 is 100. 100 plus 40 is 140. It worked. They're equal to each other. And that was the point here. What value for x makes these two equal to each other? It's 50. Okay, so that's what's in store for you today. Some algebraic practice, setting things equal to each other and solving for them. If 3x minus 10 was right here, then they're not equal to each other anymore because that's a linear pair. They add up to 180. So to solve this, you would have to say 3x minus 10 plus, so that angle plus this one, 2x plus 40. This angle plus that angle, a linear pair, equals 180. You would set it up like that. So that's how you're going to set up the equations. They're either equal to each other or you add them together and they equal 180. Are they a linear pair? Are they supplementary? Or are they equal to each other? And then you would make that 5x, make this 30, subtract your 30 to get 150, divide by 5, and x is equal to 30 here. So I'll let you try and figure that out, but x is equal to 30 in this problem. 5x is going to be equal to 150, and you'll divide by 5 to get 30. All right, that's a long video. I'm going to cut it off, and you can get to work on your do problems.